Hello, for this video I'll be discussing central limit theorem. Central limit theorem essentially states that taking a large number of samples will yield a sampling distribution that is approximately normal no matter what the population distribution looks like. This means that we're dealing with x bar and not mu because we're taking the distribution of all the means of the samples and not the true mean of the population. So, say for example you took a sample of wages from students and teachers, you'd probably get a bimodal distribution since the students' wages would be clumped together at the lower end and the teachers would be clumped together at the higher end. So no matter how many samples you take, they're all probably going to be bimodal. However, if you take the x bar of all of those samples, line them up, and sort of drop them in a pile, that pile would be approximately normally distributed. Central limit theorem is a fundamental and important rule because it allows statisticians to accurately measure the variation of sample means without having to take any other sample means to compare it with. This allows statisticians to figure out information about entire populations. Questions like, what is the mean household income of Europe, or what is the mean waist size of jeans in American males, are answered using the central limit theorem. Basically, if the population data is not normally distributed and doesn't follow the singular bell curve, then that makes it harder for statisticians to use statistical approximations. So the central limit theorem helps put that data into a bell curve for easy data analysis.
But there's a nice thing in mathematics called the central limit theorem, which tells us that under a large number of trials with a large number of objects, like 3,000 balls, a binomial distribution approximates a normal distribution, which is what you see drawn here on the board.
You can actually use a normal distribution to approximate binomial probabilities using the central limit theorem. However, that is not something that we went over in class this year, and is sort of a whole nother can of worms, so I'm not going to go into too much detail.